2.3 allows us to apply slope, midpoint, and length formulas to different questions. So let's just warm up first. Okay, so for the line segment joining AB, so for example AB, what we're going to do is we're going to find the midpoint, the length, and the slope of this line. Okay, so midpoint, capital M, AB. Okay, let's average the x's. -4 plus 4, that's beautiful, that goes to 0. 5 plus 7. Okay, so we have 0, comma, that's 12 over 2, 6. Okay, now let's find the distance. So the distance of AB, again, we're going B minus A here. So bracket 4 minus -4. Okay, so that's not going to be canceled out. Just want to highlight that. And then we're going to do 7 minus 5. Okay, so I get 8 squared plus 2 squared. 4 minus -4 is just like 4 plus 4. So I get 8 squared is 64 plus 4. Let's root. And I get root 68. I would leave it like that, but you can change it to 8.25 units. Okay, now the slope. This is small m, AB. Okay, again, for AB, we're actually doing B minus A. So let's do delta y over delta x. So for the y's, we're doing 7 minus 5. 7 minus 5. And for the x's, we're doing 4 minus -4, which gives us 2 over 8, which gives us 1 over 4. If you notice, what does this look like? The difference. And what does this look like? Okay, so the length and the slope, we're finding the difference, so we're subtracting. The midpoint, we're averaging, so we're adding them both together and then dividing it by 2. Okay, in the note, I have formulas. So I have the midpoint formula, it's there for us. Okay, the x and the y of the midpoint, that's what I called it this time. Or we can do m equals either one. Length formula, difference in the x's squared plus the difference in the y's squared all rooted. And then the slope formula, again, difference in the y's over the difference in the x's. Okay, very similar calculations, but don't get confused. Okay, example 1. The vertices of a triangle ABC are, well, A, B, and C. Determine whether triangle ABC is a right triangle. So, when we are looking for a right triangle, we are looking for lines that meet at 90 degrees, or lines that are perpendicular. Okay, what we know about their slopes is that they are negative reciprocals. Okay, so if I had triangle ABC, and it doesn't matter how you draw this looks like it's a right angle triangle in this corner, but I have no idea, I'm just throwing these down. Okay, what we have to do is we have to find the slope of all 3 line segments. So let's start by finding the slope of AB. Then we're going to find the slope of BC. Then we're going to find the slope of AC. So, the slope of AB, -1 minus 5 over -3 minus 5. Okay, I get -6 over -8, which reduces to 3 over 4. Okay, slope of BC. So we have B and C, -3 minus -1. Don't forget the brackets with the double negatives, and 1 minus -3. Okay, I get, so -3 plus 1 is -2. And 1 plus 3 is 4. So I get -1/2. So far, these are not perpendicular. They are not negative reciprocals of one another. So let's try the slope of AB. -1 minus, AC. So we have -3 minus 5 over 1 minus 5. Okay, so we have negative 8 over 1 minus 5 is negative 4, and I get 2. Okay, so if we compare 3/4, negative 1/2, and 2, we can see that negative 1/2 and 2 are negative reciprocals because this is positive 2 over 1, right? So we can conclude, so therefore, the triangle is right, or this is a right triangle. So we can attempt this using slopes. That's one method. We're going to do the exact same question, but this time we're going to use Pythagoras theorem. And this method a lot of people forget about. Okay, I find the slopes very easy. So what we want to do is we want to find the distance between, so we'll draw that A, B, and C, even though it's not drawn to scale. It looks so cute this time. Okay, A, B, and C. So we want to find the distance between A and B, find the distance between B, C, and find the distance between A and C. And then what we're going to do with those is we are going to plug them into Pythagoras theorem and see if they hold. Okay, so AB. So negative 1 minus 5, square that, and then add negative 3 minus 5. Okay. Negative 1 minus 5, I get negative 6, and we're going to square that. And then I get negative 8, and we're going to square that. So I get 36 plus 64. And we're going to root that. It's root 100, so we get 10. That's beautiful, 10 units. Okay, now let's find the distance between, that's AB, that's 10. Let's do BC. Okay, oh wow, I started with the Y's there. It does make a difference, but those should be in the other positions. Okay, so let's start with the X's. 1 minus negative 3. Okay, negative 3 minus negative 1. So this is 4 squared plus, it's 2 squared. I get 16 plus 4. I get root 20. Okay, so BC is root 20. And I'm going to leave it like that. I'm going to show you why. Okay, and now let's do AC. So we're going to subtract the C minus the A. So for the X's, 1 minus 5. And that's 4 squared. Okay, and then for the Y's, negative 3 minus 5. Negative 3 minus 5. Okay, negative 8 squared, which is 16 plus 64. Root 80. I put root 100. I'm going to show you why. Now that we have root 100, root 20, and root 80, what we want to do is we want to check if Pythagorean theorem holds. So if we did a squared plus b squared equals c squared, by default, the root 100 is going to be subbed into c squared because it's the biggest number. So root 20 squared plus root 80 squared equals 100 root 100 squared. Well, we know from before that the root and the squared cancel out on each one of these. So we get 20 plus 80 equals 100, and that is correct. That's true. Therefore, this is a right triangle. And then you make a decision, which method do you prefer and why? I personally prefer slope because I'm more used to it and we've been doing it. Okay, example 2. Show that the median from the right angle of the triangle in example 1. So example 1 is just the example above, and I already wrote down the coordinates A, B, C for us. Okay, we're going to show that that's half as long as a hypotenuse. Okay, so the length of the hypotenuse, I'm just going to skip to here. We found that it was root 100 or 10 units. Okay, so let's actually find that the median is half as long. So recall, a median joins a vertex of a triangle to the midpoint of the opposite side. So if we were to graph this triangle, so 5, 5, negative 3, negative 1, and then 1, comma, negative 3. Okay, we can see, and we remember from example 1, that angle C is 90 degrees. Okay, so we want to go from C to the midpoint. So this around here looks like the midpoint, but let's double check algebraically. So we want the midpoint of AB. So let's subtract, or let's add negative 3 plus 5 over 2, and then negative 1 plus 5 over 2. Okay, I get 2 over 2, and I get 4 over 2. So I get the midpoint as 1, comma 2. And that's exactly where we have it here, 1, comma 2. And let's call that M. Okay, now we're going to actually just calculate the length of CM. So C again is 1, comma negative 3. So we use the distance formula. Okay, so we're going to do difference in the x's. So 1 minus 1 squared plus difference in the y's. So let's do 2 minus negative 3 squared. Okay, 1 minus 1 is just 0, so we simply have 5 squared. Okay, we don't actually even have to write 25. We can just cancel out the squared in the root, and we have 5 units. Okay, so if we compare these 5 units and 10 units, we can say, therefore, the median, CM, is half as long as we can either say AB or the hypotenuse. Okay, example 3. What we're going to do now is we're going to classify the triangle CDE as isosceles, equilateral, or scalene. So let's go ahead and graph CDE. So C is 1, comma 10, D is 1, comma 6, and E is 5, comma 6. Okay, so in this triangle, we could count at least like 2 sets of the boxes, like C, D, and then D, E. But what we want to do is we want to do this algebraically, because if we're not given nice coordinates like this, we want to be able to do it using the distance formula. Okay, and just to recall, equilateral, 3 equal side lengths. Okay, isosceles, 2 equal side lengths, and scalene, none of them are equal. Okay, so I always draw it so that I can visually see that C and D connect. Okay, so C and D. So let's go 1 minus 1, square that, then we're going to go 6 minus 10. Okay, 0 squared plus negative 4 squared. So we simply just get the 4 squared, and those cancel, so we get 4 units. And that's actually very easy to like sit here and actually count. So that's 4. Let's go a different color. Okay, now let's do DE. This should be 4 units as well, obviously. We can count them right here. But let's solve it algebraically. DE. So 5 minus 1, and then 6 minus 6. So bracket 5 minus 1, and then 6 minus 6. So we get 4 squared plus 0 squared, all rooted. So all we have is like the 4 squared. Remember, This square and the root can cancel out. So again, we get 4 units. So that's pretty easy because we can just see that. Okay. We need to still solve for CE because we have to show that CE is not 4 units. Okay. So CE. So we're going to do E minus C. 5 minus 1 and then 6 minus 10. 5 minus 1 squared plus 6 minus 10 squared. So this time I get 4 squared plus 4 squared, or negative 4 squared. So I get 16 plus 16. So I get root 32. Root 32 doesn't equal 4 units. So we can say, therefore, this triangle is isosceles. Okay? But you have to show this third one, because if this was 4, then it would actually be equilateral. Okay, so this example is going to be a little bit different and a little bit more complex. So this example is actually dealing with finding the altitude. So as a little bit of a review, the altitude just means height. Okay, so when we talk about the height of a triangle, we are not using the midpoint necessarily. Okay, an example of this is if we have a triangle that looks like this, the height would be this. It doesn't connect to the midpoint. Okay, so the base and the height meet at 90 degrees. Okay, so let's read this question. A ranger cabin is to be built in a flat wooded area near the straight road that connects 2 campgrounds in a park. So we have campground A, which is here, and we have campground B, which is here. And they're trying to build a ranger cabin right here. Okay, so a new side road has to be built right here in order to connect the cabin, like the ranger cabin, with the road. Okay, and then just a note, each unit on the map grid represents 500 meters. Okay, so what we want to do is we want to find the route that minimizes cost and the number of trees that have to be cut down. So we know in order to minimize the distance, we need to go directly to the road. So we need to go perpendicular to the road. Okay, so we're going to find the root. So we're going to find the equation of this line. Okay, this is not a median and this is not a right bisector, because both medians and right bisectors go through the midpoint, but this does not go through the midpoint. So we know that this is perpendicular. The red line is perpendicular to AB. So let's actually find the slope of AB. So let's go 4.5 minus 8.5 over 10 minus 2. And what this is going to allow us to do is it's going to allow us to find a perpendicular slope, which will be the slope of our red line. We get negative 9 over 16. Oh, no, I don't. This is negative 4. And that's over 8. So I get negative 1 over 2. Okay, so our slope is perpendicular. So the perpendicular slope equals positive 2. That's going to be the slope of the red line. Now let's just solve y equals mx plus b. Let's sub in that 2 and then the point 6 comma 1.5. Okay, so I get 1.5 equals 12 plus b. Bring that over. 1.5 minus 12 equals b. Negative 10.5 equals b. Okay, so the equation of the red line, we get y equals 2x minus 10.5. Okay, so that's the root. Okay, now B. This is a little bit more complicated. We need to find the length of this side road. So here's the issue. We don't actually know we don't actually know which point this red line touches the line from A to B. So what we're going to actually do is we're going to have to find the equation of A and AB, and then we're going to have to find the point of intersection. So let's find the slope. We already have the slope of AB actually. It's -1/2. So let's skip straight to this part. Let's sub in 2, 8.5. So we have -1/2 as the slope of AB. We found that before. So we're going to sub in 2, 8.5. Those cancel. I get -1. 8.5 equals -1 plus B. And I get 9.5 equals B. So now we have two equations. Okay, y equals -1/2 x plus 9.5. And we have 2x, y equals 2x minus 10.5. Now let's find the point of intersection. Okay, the point of intersection will give us this point right here. Okay, so all I did was I wrote down the equations of the new road. So that's from the ranger cabin, and then the road AB. Okay, so now let's find the point of intersection. So because the y's are isolated, we can just set this equal to one another. Okay, -1/2 x plus 9.5. Okay, let's bring the -1/2 x over, and let's bring the -10.5 over. We have 2x plus 1/2 x equals 9.5 plus 10.5. Okay, get 20 on the right-hand side. And those two fractions, we can call it 4/2 plus 1/2x. So let's go 5/2x. Okay? We can cross multiply, the 2 comes up. We have 5x equals 40. Now divide out the 5. We get x equals 8. Okay, so our x coordinate is 8. And our y coordinate we get 16 minus 10.5. We just sub the 8 back into one of the originals. 16 minus 10.5 is 5.5. Okay, so we have the point of intersection as 8, 5.5. That's where these two roads are going to meet. Now, if you remember, the cabin is at, let's call it C, is at 6, 1.5. So we had A, we had B, and we had the cabin, let's call it C. And then this is not the midpoint, so let's call it P, the point of intersection. This is 8, 5.5. So now we need the distance between C and P. Okay, so let's do difference in the x's. Let's go 8 minus 6, square that, plus the difference in the y's, 5.5 minus 1.5. Okay, so I get 2 squared plus 4 squared. 4 plus 16, I get root 20. Okay, I'm actually going to solve like the root 20. So 4.472. And that's units. But in the actual original question, each unit on the graph equals 500 meters. So 4.472 times 500 equals 2,236. So it's like 2.2 kilometers. So we can say, therefore, the cabin is 2236 meters from the road AB.